Looking back, I've been studying sea ice for almost 50 years, and the biggest surprise was in 2007. We look at sea ice as an indicator of climate change, usually at the end of summer, when it reaches its minimum extent. In 2007, it set a record minimum by a record amount, and that changed everyone's thinking, because models had predicted a loss of sea ice, but reality was much faster. The changes that are occurring in the Arctic are having impacts on people today. Clearly, they're having impacts on people living in coastal communities where there's extra erosion in the fall. But it goes beyond that. There's the thing about people. We want to know what's happening, but what we really want to know is what's going to happen. And that's where models come in. Models ultimately run on data. And to get that data, there are several ways to do it. Here we've developed autonomous buoys to measure the temperature of the ice, how it grows in the winter, how it melts in the summer. As we go into summer, two things happen. One, that ice edge retreats, replacing snow-covered ice, which is a great reflector, with the open ocean that reflects less than 10%, which is a terrible reflector. But then also in the ice itself, instead of having this nice snow-covered ice, you have ice that's melting, that's darker. You have puddles of water on the surface, which are darker still, and it's a positive feedback. And if you're doing a climate model, you've got to get these positive feedbacks right. This is a critical time for climate change, but it's really a chance for all of us to make a difference. As people, we have to figure out a path ahead and really turn this entire global warming situation around.